Hi, and welcome to Velocro, home of the birds. And I want to get to work right away, but first I need to thank new viewers and subscribers. The channel is growing, and I thank you very much. And your sharing has really benefited the channel, and the likes and everything are very helpful. Thank you very, very much. So let's get to work because the sun is a big topic and there's tons of books on it, and we're trying to summarize it in 8 minutes. It's going to be tough. You know, most young environmentalists really do mean well, but they don't have the physics and mathematics education to make sound judgments on things like the sun, solar flares, activities. There are scientists with gray hair that have been studying this, and for the last 400 years, we have been watching the sun. So let's talk about it. What are sunspots? Well, sunspots are areas where the magnetic field is about 2,500 times stronger than the Earth's, much higher than anywhere else on the sun. They're physically way up high. Because of the sun's strong magnetic field, the magnetic pressure increases, the surrounding atmosphere pressure decreases. This in turn lowers the temperature relative to its surrounding because of the concentrated magnetic field inhibits the flow of hot new gases from the sun interior to the surface. So very much like in the plasma reactors we use in semiconductor, we use magnetic fields to control the plasma. Well, the sun does that on a really big scale. And we know that a typical sunspots consist of dark regions called the umbra and the surrounding area, a lighter region known as the penumbra. The sunspots are relatively dark because of the surrounding surface of the sun. The photosphere is very bright and is about 10,000 degrees Fahrenheit, while the umbra, the dark spots, are about 6,300 degrees, so they do appear dark. Coronal mass ejections and solar flares are extremely large explosions on the photosphere, the surface of the sun. In just a few minutes, the flares heat to several million degrees F and release as much energy as 1 billion megatons of TNT. They occur near sunspots, usually at the dividing line between the opposite directed magnetic fields, because these have a positive and magnetic fields, and you can see them pulling towards each other. It's really, it's a huge science. At any rate, let's get to work. Hot matter called plasma interacts with the magnetic field, sending bursts of plasma up and away from the sun in the form of a flare. And these flares have X-rays and magnetic fields and bombard the Earth as geomagnetic storms, and we talked a little bit about that, and the northern lights. So we'll let that go. All energy and life on Earth is a gift from the sun. All the gold on this planet is a gift from the sun. For more than 400 years, an accurate sunspot record has been kept, allowing us to draw tentative patterns between the sun's output and the Earth's weather. There's a direct correlation, but it's not predictable as desirable, so I'm going to leave a link because these 11-year sun cycles are still being understood and looked at. So I'm going to leave a link to Electroverse, who discusses this in more detail. Current data is available from NOAA, and solar experts predict the sun's activity is pretty low and below average at this time. And in April of 2019, scientists charged with predicting the sun's activity for the next 11-year solar cycle say it's likely to be weak and just generally low, and I'll leave it there because it goes on and on. However, currently the sun is in a cycle of low activity, and no one alive has seen this before. And science is observation and repeatability. So what can we expect from this period of low solar activity? So this is the great question. If you're not an astronaut, probably not too much. But they say that large SEP events, which can pose a danger to astronauts in orbit, and shock waves driven by cosmic magnetic emissions. So I'll leave a link to space.com because I love those guys. You know, weather prediction is kind of a fuzzy science, and I don't pretend to understand it, but space weather has been discussing it. They use satellites, telemetry, and computer models. So I'll leave a link for their solar activity and what they are thinking about. Because the last time this happened, we were in a Maunder minimum between 1645 and 1715, and there was a period called the Little Ice Age. Just throwing that out there. Okay, weather is greatly affected by the sun's activity, so climatologists and wannabe environmentalists need to understand the sun's function and what it is. Now, it's a star. It's not unlike billions of other stars. Most stars have orbiting satellites like Earth or other planets, and now we know that because of the Hubble Space Telescope. So there's simply too much about the sun to put in this video, so I left some links. This period of low activity is interesting because it's never happened in anyone's lifetime, so I thought it was worth talking about. And I'll leave a link to nwclimate.org, who discusses the effects of the sun and weather. So we'll leave that there. And a little note about the Farmer's Almanac, because I'm going to do a story on it shortly, because I think they have an 80% accuracy record and worth discussing. So that'll be in a future chapter. Thanks a lot for watching. Please don't forget to share, like, and subscribe. It's very important. Thank you very, very much. I must go. Gotta get back to my birds.